Dream machine. DICOM, HL7, I18 and snap. We're building the future, never looking back.
Hey everybody, welcome back to Imaging Informatics Unplugged. I'm Jason Nagels, and today's episode has been a long time coming. If you work in enterprise imaging, there's a very good chance you've encountered, either directly or indirectly, the work of today's guest, even if you didn't know it. Larry Sitka is EVP and Chief Strategy and Innovation Officer for Enterprise Imaging and AI at Paxera Health. And he brings over 38 years of experience in medical imaging and healthcare technology to that role. Before Paxera Health, Larry held executive positions at Canon Medical and 3M, and he's the founder of Acuo Technologies. This is one of the first true vendor-neutral archive companies, started way back in 1997. This is well before anyone had coined the term VNA. Larry is a contributor to the ONC's National Interoperability Roadmap, holds multiple U.S. and European patents in digital asset management, and is one of those rare people who didn't just watch the enterprise imaging industry develop. He helped build the technical foundation it runs on. In this conversation, we go back to the beginning. Why Larry built Acuo the way he did, what the early internet taught him about sharing medical images, and how the idea of separating data from visualization fundamentally changed the economics of PACS. We get into the real state of DICOM interoperability, and let me tell you, it's a lot messier than most vendors want to admit. And then we spend a solid chunk of time on AI, not the marketing hype version, but the practical, what actually happens in production version. Larry has been working with inference engines for over a decade, and his take on how imaging AI is being integrated right now is definitely worth hearing. We also talk about something that doesn't get discussed enough, the knowledge gap. As the generation of engineers who wrote their own DICOM stacks from scratch, as they start to retire, that deep expertise, it doesn't automatically transfer over to the next generation. And honestly, it's a big part of the reason why I've built out a lot of the course programs and hands-on learning labs that are available at nagelsconsulting.com. Shameless plug. Because that structured hands-on knowledge has to come from somewhere. Larry's take on what the next generation needs to do to fill that gap is definitely worth hearing. This is a long one, but it's worth every minute. So with all that said, let's jump into it. Thanks for joining, Larry. We were just having a conversation offline before I hit the record button, and you were talking a bit about starting Acuo, and there's balancing the business-driven mindset where you need to have that mindset. You want to be successful for your organization, but also kind of balancing that out with the ultimate goal of providing quality products that are going to benefit patients, benefit clinical users, and so on. I want to take us back to that time period. I think it was the late 90s, 97. Is that correct?
97.
97, you get the itch and you start Acuo. And so the time period is interesting because the word VNA had not been discussed or brought up as yet. Did you have a clear vision of what you were building in 1997 versus, when I think you exited in 2014? Is that correct?
Well, so I sold in 2012. I had a 4-year earnout.
Okay.
So I left in about 2016. I left, the Acuo organization, which was acquired twice, right? Once by Lexmark and Perceptive, and then the second time by Highland, and it's still owned by Highland now. But so I had the luxury actually prior to starting Acuo of every single job I've had in my entire career kind of has been skunkworks. From Bell Labs, where I wrote network drivers for things that didn't even exist, or I wrote inside of when I went for a company with 3M, right? We were looking at a company called CMAX Icon, and I got into medical imaging in that construct, and they gave me this ACR NEMIS 2.0 standard, right? And said, go build this. I did that, and then they had me refine it with the DICOM 3.0 standard. So in other words, everything I was building was a skunkworks. I had the pleasure of building 2 PACS systems, right, inside of that. One was called, we bought it from an organization on the East Coast where they had built it and created it. And it was a Mac-based platform. And then
wow.
And then we acquired CMAX Icon, which was all Mac through and through. Okay. And that's where I really got my dig into DICOM 3.0 and then working on the standard in DICOM 3.0. So I worked with a couple of other individuals on mostly the print service class. Obviously 3M built the lasers. So then they told me, go write the network interface for the lasers. So building 2 PAC systems, and then I had the pleasure of doing 2 archival systems. And I said, hey, I got this idea. And I come from an system enterprise background, and everybody was focusing on data this way.
Mm-hmm.
Well, I want to separate data from human-based interaction. So in doing so, I created this idea of abstracting data from visualization layers. And when I did that, I saw the cost of those PAC solutions go down, and then you could turn the storage into go compete.
Mm-hmm. Mm-hmm.
Came a bidding war. So the prices was driving down the total cost of ownership in the organizations. It also then allowed me to say, okay, the first issue I ran into is these goofy migrations. And migrations twofold, right? One from application-based migrations, the second one to a storage-based migration, right? Because the trend was always to read data out of the application and store it into another application. So you were data locked there. And then you were also data locked into that storage, because typically that vendor used a proprietary format.
Mm-hmm.
Well, if I was all about standards. So I said, if I create a standard-based interface to those and separate, the ROI, makes it easier. You can bid your packs out, right? And get them to compete for visualization. And I was coming at it from the enterprise level. And, in that time frame, I really focused on what I call persisting data, taking it in, storing it, and managing it. And now, about 10 years ago, I made this shift about when I saw AI coming about. My first foray into enterprise AI inferencing was about 10 years ago. So, and inside of that, the problem I had is I was going to go build an inference engine,
Mm-hmm.
algorithms. So the reason I went over to Canon Medical Systems is I looked at their product called AV. Right? And if you ever use the Vitria product, you open up their application, you click a button, it runs an algorithm. I said, we can just pull all those out and put them all in the inference engine, and boom, there we go. They're doing that now today. Okay, but I couldn't convince them to do it. So I said, I really believe in this. I believe in what I'll call not a static VNA, but a dynamic VNA.
Mm-hmm.
So I even corrected myself with Acuo going from data persistence. I'm now focused on data perception, meaning what is it telling you? Why the reason to store data is to look at it again. Humans can't do that, right? They just don't have. So this whole new servitude to a different user, ultimately everybody serves this thing called the patient, right?
Yes.
And what can we do to benefit the patient? So in going forward, if we can take and use or separate data between visualization that serves humans versus, machine visualization, this side of the environment runs at 100 times more capacity than this side.
One of the challenges when people are starting out on their journey of creating a business and you find your niche, so you've identified what the requirement is, your solution starts doing it well, and then all of a sudden additional requests start being made. I would imagine at this time in the late 90s, early 2000s, when people see a high functioning archive system that's allowing the PACs to offload a lot of the local performance and compute now, I would imagine requests started coming in, and when's the PACs coming? Was that a temptation that you looked into? How did you handle that?
Well, the budgets, that's where the budgets were coming from. Right? Nobody had a budget for a VNA, right? Mm-hmm. So you had to go in and justify and define it. So the money was typically radiology, and they're going out for PACS RFP. What I did discover quickly is because of the QA and QC functionality that's required, you do need a viewer, right? So we did, after about the first 10 or 15 years, where we actually purchased a company called Claron Nil at the time, to provide an enterprise viewing solution into the VNA. And then we grabbed another company called Paxgear and bought that company at the time. So they're all still part of that same, group inside of Highland. We did that again because most people don't understand. They all think VNAs are about storage. And they're really not. They're all about correcting, misconceptions in DICOM, correcting, malformed data in DICOM that's generated. It's kind of interesting. VNAs, when they communicate, they don't just talk to one or two or three. They talk to thousands of independent pieces of software, and you have to make up for the misgivings of all these. And this is where one of the things, even so, I've written the DICOM stack 3 times, right? Twice inside of, once for 3M, once for CMAX Icon, once for Acuo. Okay. And inside of each of those, when I read that standard, it was different. My outcome was different. And I remember the day we all went down to, the basement garage with Sen was there, Malincrot was there, and even they spent half a day trying to just communicate, right? So, and why we pretty much sat there, and it was all about interpretation. And that's the biggest problem is the standard. There is no conformity test. There is absolutely no conformity test, which creates this interoperability problem, even on the storage side.
That's one of the interesting things with DICOM, I find, is if I have an IHE integration statement, that means that I have gone to Connectathon. There has been a validation of my ability to be able to say that I'm doing this actor. Whereas if I have a new product, I can, hire someone to write me a DICOM conformance statement pretty quickly.
So again, when I wrote network drivers, right? TCP/IP, I wrote a stack for that. I wrote a Ethernet driver, token ring driver, ATM, sonic ring. Those are all things that I did early on in my career. But I always had a finite state machine. I could take my solution and drive it against that finite state machine. They'd give me a pass or fail. Then they'd give me a graded score. And then they would give me suggestions how to benefit the interoperability to conform to the IEEE standard, right, for that MAC layer. And that, I think, really allowed for organizations to just plug into networks. You know what I mean? The interoperability.
Yeah, I can't imagine. It's not guesswork. It's either a yes or a no that it's going to be compatible.
And I got to tell you, some of the stuff that I've seen in DICOM that comes from some of the vendors, I'm just amazed the chest x-ray gets read. It's like, the analogy I typically use is, would you settle if your bank account was missing a zero? That's kind of what DICOM is doing on the network, right? It's just, which is really scary, right? But there's all these error correction things that have to occur in the message orchestration. And most of it has to do with, lengths of fields, or it has to do with descriptions or malused fields, or it has to do with, endian flipped, and they do one, but did it for everything else. I mean, the number one thing was photometric interpretation. Kind of basic to viewing an image, right?
Yeah.
Can only tell you that it's frequently wrong.
I find it funny when you have two vendors that are interpreting the spec. They're reading the standard exactly the same verbiage, and it's like a Christopher Nolan movie. They both watch the same thing and they walk out thinking something different. And I've seen this before within Canada when we were setting up regional VNAs, but we didn't call them VNAs back then. We were calling them DIRs, Diagnostic Imaging Repositories. And so you have this coordination from very big PACS players, big market PACS companies, and they are in the same room and they are debating the interpretation of how the standard should be executed.
Yep. It was all about, in a vendor-based environment, it was all about, if I have the data and I store the data, I own the data. And my philosophy was completely different, right? When I started Acuo, I didn't want to own anything. I didn't want to own storage. I didn't want to own data. In fact, when we would install software, right? When we would install the Acuo software, I didn't even have to have any data stored. Actually, all about message orchestration and collaboration of pulling all these different service lines together, and using just the context of DICOM to link them, to make them look like one, so. And then doing the same thing, with I got the idea actually from Napster, if you remember.
Yeah. I spent many hours on Napster.
That was the principle behind Acuo, right? I said, hey, I could do this with medical images, and sharing of context of medical images. But inside of that, there's conformity, right? You have to, now that conformity just got worse. So we as humans, when we look at data and you see that missing zero and you in your bank account, you say, oh my gosh, right, this is wrong, and you can go correct it, or you just override it and ignore it, or in medical imaging, a brain in a Brian study, you know it's a brain study, right? But if you send that to an AI algorithm, it doesn't know what to do with it.
Mm-hmm,
It has
mm-hmm.
no idea. So, data normalization is something that's mandatory now, absolutely. And it's normalization just mapping through mapping and morphing, or even through by connecting to a terminology service, right? And making data accurate. And then there's many things that can be done prior to, even storing the data, right? Body part labeling, volumetrics,
Mm-hmm.
labeling, spine labeling. Those are things that can be done. And then once you have the volumetrics and you identify the body part, now you've organized that structurally, and you can say, I have 10 algorithms here for the 5 body parts that I have here. I can run all those. So instead of just using that little study series description, you can now actually use the pixel data and reference, let's go look at all these body parts and use all these algorithms. And by the way, we know that there's a lot of false positives, in some of these. And it's AI developers, they're erring on the side of safety, right? If they think it might be, they call it out.
Mm-hmm, mm-hmm.
That's causing massive chaos with the radiologists, right? These false positives.
Which we saw as a big reason why there was such a drop in adoption for CAD markers. It's only useful if it's helpful. And if every single mammography exam I'm looking at has a bunch of potential calcification scores that aren't really there, that's a waste of time.
But an example, like when I found out I didn't have a left kidney, I'm like, oh my God, I don't believe this. What did I do? I went and asked a second opinion, right? I asked a colleague, a radiologist that's a colleague of mine out of Florida. And I said, hey, am I missing a kidney here? And he goes, yes, you're missing a kidney there. So it's AI second opinioning is what we need to start. So rather than just get one, CAD, the agentic-based AI I've been doing for 20 years, right, with CAD. What I'm talking about is using your inference engine to not just run one algorithm, run 4 or 5. Do they all? Well, to get that agreement, you need a generative AI that sits on top. And then it says, yes, this is based off of 4 findings, not 1, 4. Okay. And if that's the context, probably is, right? It probably is a positive. So that's what I'm talking about. And I didn't make these ideas up. Again, so my first foray into medical imaging was 88. But prior to that, I was in the networking environment, right, with Bell Labs. I saw a lot of bank transactions and a lot of financial institutions, very specific. So I was watching how they were doing their modeling, right? And they ran it every single night, not just one, but dozens, okay, running on these big MVS hopes. And they would get findings out of these models. And then they'd have another service layer that sat on top that said, what do these mean? And it would kind of give a palatable reference for human beings to actually make a diagnosis for a buy or sell. We're doing the same thing here now in healthcare. So that's the architecture that I'm proposing. It's not top down through the viewer. It's actually bottom up. And it's got to be designed to run not at a few thousand studies, but at hundreds of thousands of studies every single night.
What do you think of, you're demonstrating a very rich historical knowledge of foundational IT principles. And so you have not just the knowledge, but the hands-on experience, and that's carried you forward, and you've been able to find patterns and identify lessons learned from building out network drives to what we can do today here in imaging. We are in a bit of a transition with the generation of baby boomers that are ready to retire, are getting already retired. And then, there's a rich wealth of knowledge that is leaving all industries. What do you think as far as AI is looked at as an opportunity to help some of the smart young people that we're bringing on? I think it's a bit of a double-edged sword in the sense that there is real skill degradation that starts to happen, and you start to miss out on those foundational understandings. But again, maybe you don't need to know those foundational things as well. Like the devil's advocate approach is, I used to be able to fix my car quite easily and from a mechanical perspective, and now I don't have to do that. I don't even really understand how it works.
You're spot on correct. It's funny. Dr. Siegel and I were talking about a year ago. We were at a SIIM conference, and I said, I watch all these vendors today, and they're all using these toolkits, right? And these developers are using toolkits, and they're relying on the toolkits. And when you start to ask very implicit, deep, detailed questions around the DICOM standard, like extended SOP negotiation, context IDs, and how that works and how it's actually tracked. Nobody has any idea, nobody has. And there was a post, I can't remember. I think it was Herman Osterwig posted it. He was talking about, hey, how come the context ID only allows one byte in length? And that was, I remember very distinctly talking about that because I had just gone through TCP/IP and looking at, the IP addresses and saying, oh, we're going to reach that limit at some point in time. And sure enough, IP6, right? You have some. So what does everybody do? They have use internal IP addresses. You can't do that with DICOM, right? You're limited to only 200. Mind you, when we created that standard, there was maybe 15 SOP classes, right? Now there's hundreds. Well, every SOP class is one context ID, but every transfer syntax is another context ID. And nobody realizes this. So they don't understand, why errors are occurring and get rejected. So we both talked about how can we, because I'm a baby boomer, right? I got a few years left and then, which is why I'm really concerned, right? I'm very concerned in terms of what I see for the patient population that sits out there, which is why I wear my patient hat. But I actually challenge a lot of the developers, right, inside the vendor organizations. Don't become a passive learner. Meaning, because AI will do that to you. Right? You just have to watch something to get it. Go dig, right? Go dig. Understand why bytes are being swapped. Understand, what words, mean inside, word lengths. What's the difference between, the value representations, in the different DICOM fields?
Yes.
Those are things that they have to understand, or they're never, like that photometric interpretation, they're never going to understand why it's reversed. They're just going to say, I've never seen this before, right? How do I fix this? Well, you end up writing something that morphs it into, that flips the bytes. And it typically is caused because somebody used or created an application that just didn't know. So toolkits are wonderful. Just understand, the toolkit and what it's doing and why it's doing or what it's not doing, right? Take the time deep into those. You have the source code, use it.
I had a similar conversation with Wujin, and he was discussing skill degradation from the radiologist perspective, but it's across the board. There's a generation before me that was much better at mental math than my generation, just by purview of calculators were a lot more acceptable in academic centers. And so you're not working out that muscle to the same degree. And it almost speaks to fostering curiosity, and this is where it's going to get interesting. Is I wonder if there's value in pairing these types of educational paths that we deemed as being more enjoyable and exploring curiosity, arts degrees and things like that, or philosophy, and you pair that with science, the maths and all that. And this is where now I don't need to know the ins and outs of the foundation, but if I'm curious enough to understand the value representation and what each of these mean and how it's a toolbox for the construction of what I'm allowed to put in this tag.
Well, I also think we as vendors have kind of let the industry down. And I say that primarily because we ask our user, right, which in the minds of every vendor, the users in this space is the radiologist. But what have we done for them? We've actually made their job harder. The first packs that it was you could run in landscape mode, right? You can't run a PAX in landscape. You have to run in portrait because the drop down is so big. So what do? They create these hotkeys. If you ask a rad what would make their life easier, they'll say some feature, some function, or another screen. And again, now we have to start to think about, and this is the analogy that I use. You can't text and drive. You're looking at this window and you're looking out that window and you're driving that car. And anytime you look down like this to see that text, you break that synaptic pathway and you go look at that and you look up and you crash. This is why we now have heads-up displays that show the speed right through the windshield, right?
Mm-hmm.
And the speed limits even. Look what we've done to the radiologist. Look what we've done to them. Their job is to take the current study and look at what the anomaly is in that study. Unfortunately, we added this thing called the EMR. They got to go look at that. Now that we've added the reporting, we got to go look at that and all the relative prior reports. They got to go look at that. Now you're throwing yet another thing, which is AI, that's got reports and, oh, by the way, another viewer and another widget, right? That you have. It just, we're making their job too hard. We need to stop the context of looking at AI as an outsider and actually go back and rewrite our enterprise systems to incorporate and leverage AI. So it's immutable, right? To the physician. It's inside. It just gives them the result right in this pane of glass. Not over here, not down there. That makes me go do this, right? And that's what I'm talking about. Perceiving the data, not persisting the data.
Yeah, your general radiologist that is not an informatics geek radiologist, like, all of our friends, but you shouldn't even have to know what DICOM is or anything of the nature. It's just standards are invisible when they work well. And then I like your idea of the analogy of driving and texting, because there's been studies, which I don't have the statistical data to share right now, but every time the movement of the head is away from the image and it's focused on something else and then back on the image, there's a complete reset that has to happen and reframe them back to the orient or what they were looking at originally.
They don't want to see the obvious. That big anomaly right in the middle of the screen where they're looking, they're going to see that. They want to know everything around the edge, or I'm looking at the kidney. What about the pancreas? I mean, that's what now, I just saw this Mayo study, right? Where 3 years in advance, they can pick up pancreatic cancer, through an AI-based algorithm. That's AI. That's AI things. So now they can take that algorithm and not just run current studies, but go mine the environment, right? Go look at any study that they could possibly have a pancreas inside and look for it. That's AI, right? That's AI. And that's where you need the performance is changing so dramatically. Again, I just was on with a site. Are you sitting down? They do 1 million studies in a 24-hour period in an AI. So there's no PACS that can do 1 million studies in a 24-hour period. You'll probably take you hundreds of VMs, right, to share that amount of data. And that's just not economically possible. Going back to the drawing board and rewrite your application with an enterprise approach instead of an application approach.
We've mentioned AI a number of times in this conversation. If you were building Acuo today as opposed to 1997, how do you imagine the experience would be different? Building the tools, I guess, getting funding, all of the things that you did back in 97, do you think you would approach things differently?
Well, a lot of the investors, they look at reputation. Okay. So in other words, have you done this before? And I was just this 30, 35-year-old kid that, I'd never done this before other than saying, I did skunkworks projects, at Bell Labs and 3M and whatever. So I struggled for 3 years. I did probably 40 presentations to VCs, and I found an angel investor who just believed me. He had no idea what I was talking about. And in fact, I met with him roughly 6 times, and I gave him the business plan again, the 6th time, and he pushed it back at me. And he says, you know what, Larry? He goes, you're asking for $1.5 million. He goes, how many times have we met? And I said, 6. This is our 6th meeting. He goes, I actually could have made more money in that time frame than what you're asking for. I just want to find out how serious you are. His name is Jim Junt. He acted as an angel investor, right? He did put someone into the company to make sure, right, we were being fiduciary responsible. And so I think differently now. It would be easier on the fundraise. Big lesson learned was it has nothing to do with tech. Everything to do with, are you solving a business problem? And is there an ROI inside of that business problem? And once you have that, it's an easy play, right? It's an easy play in terms of raising, right, of funds. What I will say is, given in that time frame, right back in the 90s, there wasn't as much data, right? And as I look now, probably the data volume is 1,000x, right, that it was back then.
Yeah.
And the number of vendors is 100x, and you even have some of the proprietary stuff. Even the PAX vendors, right, are doing their proprietary stuff. Being able to do those integrations, I think, have become far more difficult because it's kind of like the Wild West.
Yes, very much so.
And from my capacity, my learning has gone from not about, and I keep driving this home, not about persisting and storing the data, but what the heck is it saying to me, And if we're going to keep, why do you keep data?
Yes. Yeah.
You keep it to use it. Well, humans just don't have the capacity to go back and look at everybody's studies from the last, 25 years and see, are there any differences or anomalies you can pick up in those studies and start comparing cross-modality analysis, right? You have, chest x-ray. Well, now you've got a CT. Is there something that you saw 25 years ago that today you saw with that CT that could be different? AI, right? Going back and mining the data. Humans can't do it, even just statistics.
Yes. Yeah.
Humans, it takes humans multiple spreadsheets to look at this data. So the other construct, right, that I've learned is I look at what is a patient. A patient is a crisis to a cure. A patient walks in sick, a patient leaves healthy, and then beyond. Okay, there's more to it beyond. So where do we start? We start at the metadata, but the problem is you have DICOM metadata, you have HL7 metadata, you have these OMOP exports right out of the EMRs now for discrete content. We're putting them all together in open source Elasticsearch, not for humans, but for AI and AI development to do these wide queries.
Mm-hmm.
Relying upon DICOM to do these, there's like 15 fields in DICOM, right, that they query upon. That's it. Call them 15 fields. Everything else is type 3 and you just ignore it. Well, AI doesn't have to do that. AI can actually go to the metadata source and do these wide queries, right? Find me Dr. Smith, every CT they did on a Sunday night between the hours of 11 p.m. and midnight, that had contrast. You can't do that in DICOM. You can't make, you can do Wato-based retrieves and then go parse it all apart, but it's too consuming. You need a vector database to support that. So you need a hierarchical and relational database and database model to support DICOM. But then to support AI and advanced analytics, you need a vector database.
One of the things I find is, because you make a really great point about the collection of data, like we are in a riches about the amount of data that we have around us. Here in Canada, we have regional repositories so that, very useful. You can start mapping out population health and trending. We've had a Toronto-based company on this podcast before called 16-bit, where you can look at an old X-ray and it will go through their model and give you a prediction on fracture likelihood and get ordered a DEXA scan, and that could be really helpful for the patient in the long run of predictive care and being ahead of things. But it's the people and the governance that is sometimes I think is the big challenge. We know that we can get the database made, and we know that we can create the interface points to be able to pull the data into a model, but convincing, whether it's at an institutional level or a regional level, and within that institution, many different committees and boards that have to get involved. And I find if we wanted to tomorrow, technically speaking, we could do so much, but I'm not saying we have to cut the corners on every process, but sometimes it feels like process really is the anchor that gets in the way of progress.
You're right. You're actually right. And so one of the principles of VNA is data separation, right? Tenanting, multi-tenanting, being able to separate, but it also means not just tenant by site or institution or specialty, but tenant by production and research, right? And being able to create a research environment that mirrors my production environment without impacting production. So, and that's where what terrifies me the most about AI is it hallucinates.
Hmm.
I can prove it. I can open up GPT and I can prove it'll hallucinate today, period. Because it's only as good as what you train it upon. And it just gets more and more and more focused, which is great for the cohort of data that you're giving to it, but really bad if you get this outlier that comes in. To make it even worse, I now see it being impacted by the modality vendor. A change of the modality vendor impacts the AI performance and the findings side of it. So what I believe the next evolution for enterprise imaging, right? And I'll say PACS VNA is a governance engine, right? A governance platform for managing AI. And I use the correlation. We used to have to recalibrate the monitors. Remember biomedical engineers running around recalibrating the monitors? And then before that, we actually had the laser imagers. They would degrade over time, right? The chemicals would degrade. You'd have to go in and tune, and even the lasers on the dry products, right? You'd have to go in and you have to replace lasers, or you have to, make modifications and tuning for them. Thus created this thing called the SIMPT pattern, right? That we would always, train the lasers with. Well, the same is true with AI. You're going to run AI over a time period, but nobody's pulling them back out and making sure they're still in context of the cohort they were trained on. So the thought process that I have is that instead of making one for all, let's make one for a very specific set of parameters, right? Because we're just different. As humans, we're different, right? I'm Northern European in descent, so I need algorithms that can manage, right, or produce findings for Northern Europeans. I sat on a couple of advisory boards, right, for a couple of AI companies, and one, when they brought their algorithm over here to the US, it ran perfect because it was built using Northern European descent, which is the typical, right, cohort group here in the US. However, another one came from South Korea, and it was really bad when it first started here. Now they're getting much better now that they're, well, why not just create algorithms with specificity, right? For those smoker, non-smoker, shipbuilder, miner, ethnicity. I'm an Asian descent of Northern European descent, African American descent. We're just all different. And as a patient, I want that boutique medicine, right? I don't want a generalization finding, and then they'll put me on some drug that they don't even know how I'm going to react. I want to know exactly what my finding is based off of my genetic makeup. And that's the other context. So we're now putting the onus not just on the medical imaging side, not just on the discrete content, but now you have this third leg of the stool, right, for healthcare, which is the, the biology side of the business, the genetics, the genomics, right, the liquid biopsies. Let's put this all together to focus on wellness. If you ever have the opportunity, there's an organization out of Bangkok, Thailand called Bumangrat. I am so impressed by the way they treat their patients and how they do. They do a genetic makeup of their patient. And then so they have their basis, right? They have their baseline. Then they do a liquid biopsy every single year. Well, in that liquid biopsy, they get rid of all the good stuff. And I'm not clinical, so I'm really simplifying this. They spin out all the good stuff and they look what's floating around in the blood sample. And it's typically genetic makeup of cancer or a tumor or something. And they know what those are. So they can begin treating very early on. I have a colleague that I worked with for many years. He ended up having colon cancer and he has a colostomy. And he said, you know how they check me for cancer now? They do a liquid biopsy. And he's like, why couldn't they do that before? And I said, they could. It's just nobody brought it forth, right?
Yeah.
If you're in a high risk group, why not find it sooner in the bloodstream, whatever disease it may be, right? The other thing, is we really rely upon the patient at the wrong time. They're in there for an emergency and we say, what's your history? They don't remember,
No.
they don't remember. I don't remember. So it's like, so being able to definitively define that or go discover it, based off of pure science and fact, that's what we have to do.
This has been a great conversation. I've got a bunch of follow-up questions I'd love to hit you with, but I think we're hitting close to the hour. So what I'd like to do now, maybe we can have you back sometime.
That'd be
Um,
great. That'd be
uh,
great.
how about you just close out? Let us know what you're up to. I think we've got SIIM on the horizon. So if anyone wants to talk to you, where can they find you and all of that?
Yeah. We will be at SIIM. I will be at SIIM. We'll be attending. We'll be showing AI-based integrated VNA, AI-based integrated PACS, and then an AI governance platform, ARC, all as an enterprise imaging solution, all working together in unification. It's an environment, again, I think is mandatory now for enterprise imaging. I mean, just in the way I'm watching and the way I'm following. So very excited about, the construct. We're in when I joined Paxera a little over 3 years ago, I told Dr. Shura, I'm going to blow it all up. He looked at me like, what are you talking about? And I said, we have to redesign, we have to re-architect, right? Everything that we've done. He had built ARC, but I said, I want ARC to use and leverage the VNA directly and natively as an AI governance platform, not as a, yeah, you're going to build algorithms, but hey, you got to manage those algorithms, and that's the hardest problem. So we can show that, also as we go forward. And then we can talk a bit about our vision for the future in that, using MCP services and MCP servers sitting on top of all our applications. If you look at technology's trend, right, and how, we've gone from using, first it was turning the TV like this, right, and then it was a remote control, and hey, I could run that remote control in the dark. That's where we're at right now with radiologists and their hotkeys. How do we move from there into, hey, Alexa, watch the Minnesota Wild hockey game, set the DVR, set the sleep timer, set the volume, and I'm done. AI, in my mind, is additional information to assist the physicians and assist the patients.
Well, that's a good way to end it. Thank you very much, Larry. I really appreciate you taking the time today.
All right. Thank you.
Interoperability, the dream machine. DICOM, HL7, IHE, and Snap. We're building the future, never looking back.